In this video, I'm going to look at another example on integration by parts. So let's suppose we have this problem, the integral of secant cubed x dx. I want to find the antiderivative of the integral of this function here. Okay, so here you have the formula u times v minus the integral of v u prime dx. So remember here the procedure is to identify u and v prime from this integral right here. So we have just one term here, but we can break it up. Secant cubed can be written as secant squared times secant. And we can take the derivative of secant and we can integrate secant squared. So the choices here then would be to let u equal to secant x and let v prime equal to secant squared x. Okay, so again, we want to select u so that we can take the derivative. We want to select v prime so we can take the antiderivative. Okay, so from here, u prime derivative secant of x is secant of x tangent of x. Okay, and over here v prime equal to secant squared. We can find v from that antiderivative, or the integral of secant squared is tangent of x. Now once we have that, we simply make the substitution for u, v, and u prime in this formula right here. Okay, so the way this is written is secant cubed of x dx. There's no specific formula at this time to find the antiderivative, so we're hoping that this integral over here will be easier to integrate. Okay, so we make the substitutions. Where I have a u, I'm going to put secant of x. Where I have a v, I'm going to put tangent of x. And over here for u prime, we're going to put secant of x, tangent of x. Okay. So this is what we wind up with. Okay, so uv, secant of x is u, v is tangent of x. There it is right there. And then I have the integral of tangent of x. Okay, for v. And then right here we have u prime, secant x, tangent x, dx. Okay, then we're just going to simplify here. Tangent x times tangent x is going to give us tangent squared for this integrating right here. Okay, so write the whole thing again. And all I did here again is just simplified here. Tangent x times tangent x is tangent squared secant x. Okay. And then the problem, then we want to integrate this. Okay, so the way it's written there, not that easy to integrate. So remember though that tangent squared x is well, first of all, 1 plus, so let's write it up here, 1 plus, this is one of your Pythagorean identities from trig, 1 plus tangent squared x is equal to secant squared x. And then from this right here, solving for tangent squared, I can replace this tangent squared right here by secant squared minus 1. Okay? And then I would multiply that by secant x, so this would give me secant cube of x minus secant of x. Okay? So again, making the substitution for this right here, and then multiplying by secant of x, I will get secant of x cubed minus tangent, or minus secant of x, I should say. Okay, so in other words, this will become this. Okay, so just breaking it up into two integrals here, so the minus secant cubed is right here, and then minus there will make this the integral of secant x dx. Okay. Now this integral right here was already derived, okay, or is the formula for this one right here. This one right here has an integral of ln of absolute value of secant of x plus tangent of x. Okay, so this is easy to do, just from previous solutions. And now look at this one right here. It's the same original integral. I got minus antiderivative of secant cube of x dx, but that's the same thing as this one. So obviously we're solving for this integral right here, so the technique in this one right here is to simply bring this over to the other side. Bring this over to the other side. It's just like having a minus x here and an x over here. We bring it over, we get 2x. Okay, so this is simply going to become twice the integral of secant of x dx will equal 2. Okay? And then everything's going to stay the same. So this will then, this and that will be secant of x, okay, from right here, tangent of x. And then I have plus ln absolute secant x plus tangent of x. And then to finish the problem, then I would just divide through by 2. So dividing by 2, this will cancel out. This would put a 2 here. This would be the 2 over here, down here. And then at the end I add my constant of integration. There you have your answer, right here. Okay, so let me clear this. And there it is again. Okay. So the integral of secant cubed dx is equal to secant x tangent x over 2. You can put this as the coefficient of 1/2. I have it this way. Your choice. And then over here, ln of secant x plus tangent of x plus c. That's your solution. Okay. Thanks for watching, and we'll see you in the next video.